Hello everybody, and welcome to the beginning of Chapter 6. We are looking at page 124 in our workbook, and this is an introduction to complex numbers which are going to play a role in this last chapter of our course. Okay, so let's start this discussion with a question in the preliminary example here together. Does the equation x squared plus 1 equals 0 have a solution? Okay, well, if we approach this as just an ordinary algebra problem, you could think of this as just trying to get the x by itself here. So we would subtract 1 from both sides. And then what we're asking is there a number whose square is equal to -1? Okay, well, that's an interesting question. If this were a real analysis class, we would have to say the answer is no, because there's no real number that we can square that would give us -1 as a result. But if we're willing to extend our number system a little bit, the answer to this question is yes. Okay, so let's go ahead and take the square root of both sides. Okay, there's going to be a plus or minus possibility. And since square root of -1 is not a real number, we're going to need a new name for it, and we're going to use the symbol I to represent the square root of -1. I is an example of what's known as a complex number, and we're going to explore some of the properties of complex numbers in this section. Okay, so to get us started, let's just make a couple of algebraic observations here about this number I. Okay, what we're going to do is just raise I to some powers and notice kind of an interesting pattern with how the powers of I behave. Starting with I to the first, which is obviously just I. What would happen if we took I and squared it? Well, we defined I to be the square root of -1, and if we square that, we should get back to -1. Okay, what about I cubed? Well, we could write that as I squared times I, and notice from above that I squared is -1, so I squared times I would just have to be -1 times I, or -I. How about I to the fourth? Well, that's I squared times I squared, so it's like taking -1 times itself. That's going to get us back to 1, interestingly. And after that, kind of interesting that we see a repeating pattern, because after all, what is I to the fifth? We could write it as I to the fourth times I, and from above we can see that I to the fourth gave us 1, so the thing that I just circled there is actually 1. So we've got 1 times I, which is I, and that returns us back to the very first line that we started with. Okay, and you'll see that the pattern just continues. I to the sixth we could write as I to the fourth times I squared. That's 1 times -1 if you look at our steps above, which is -1. That agrees with the second line, and so on. I'll let you confirm these last two calculations. Okay, so we'll just make the comment that this pattern that we're seeing here repeats indefinitely. Okay, so with that observation, let's do a quick example here together. Okay, example 1. It would like us to do some arithmetic with complex numbers. So we've got a ratio, 2 plus 3i over 5 minus I, and it would like us to write our answer in the so-called standard form, a plus bi. Turns out that every complex number can be written in this standard form a plus bi if we're willing to do a little bit of algebra. Okay, how does that work in this case? We're going to borrow an algebraic technique that you might remember from an algebra or maybe a calculus class. Specifically, we're going to multiply this fraction on the top and the bottom by what's known as the conjugate of the denominator. Okay, so we started with a 5 minus I on the bottom. We'll multiply the top and the bottom by 5 plus I. That's algebraically legal as long as we do it on the top and the bottom, because it's like multiplying this number by 1, which doesn't change it. Okay, and now can just go back to, you might remember the word FOIL from algebra when you multiply two things like this and this together. So we'll FOIL out the top, starting with 2 times 5 gives us 10. Then the two inside terms give us a 15i, the two outside a 2i, and then finally plus 3i squared for the last two. And on the bottom, if we multiply that out, we're going to get 25 minus 5i plus 5i. There's the inside and the outside, minus I squared. Okay, what does that simplify to? Well, we can do a little simplifying in the numerator. And 15i plus 2i is 17i. What is 3i squared? Well, above, we notice that I squared is negative 1. And so 3i squared should just be negative 3, a real number. Okay, and notice that down below something kind of nice happens. We've got a minus 5i plus a 5i. Those go away. And what's left over? Let's see. 25 minus I squared. And again, I squared is negative 1. So notice what has happened in the denominator. All of the instances of I disappeared, and that was kind of the purpose for multiplying by the 5 plus I. We wanted to turn the denominator into just a real number, and we did that. Okay, so continuing here, looking at the numerator, we've got a 10 minus a 3. Let's put those together and write it as a 7 plus a 17i. And in the bottom, we've got a 26. And finally, to write this in the standard form, a plus bi, we'll just break that up into two pieces. 7 over 26 plus 726i. There's our answer. And that's equivalent to the number that we started with. We've just written it in this special form. And one last comment, that we can do that for any complex number. We can write it in this standard form.